In Kansas, electrical lines buried underground have minimum depth requirements. According to the Kansas Electrical Code, specifically Article 300.5, titled Underground Service Cables, there are specific regulations. For the first 10 feet from the building being supplied, the cables must be buried at least 18 inches deep. Beyond that initial 10-foot section, for the remainder of the run, the cables must be buried at least 12 inches deep. This requirement applies to all electrical lines buried underground, which includes those running from a home to a detached garage. The Kansas Electrical Code also specifies the dimensions for the trench in which these underground service cables are to be installed. Firstly, for cables up to 4 American wire gauge, AUG, the trench must be at least 6 inches wide. Secondly, for cables larger than 4 AWG, the trench width must be at least 9 inches. Thirdly, regardless of the cable size, the trench must be at least 12 inches deep for all cables. It is critical to adhere to these requirements. Failing to comply with the minimum burial depths and trench dimensions could lead to a variety of problems. Firstly, shallowly buried cables are more susceptible to physical damage. This damage could come from digging, landscaping activities, or even the settling of the ground over time. If the insulation of the cable is damaged, it could create a safety hazard. Secondly, damaged cables can cause electrical shorts or ground faults, which could result in power outages or even electrical fires. Thirdly, not following the code can also create liability issues. For example, if someone is injured as a result of improperly installed electrical wiring, the homeowner or installer could be held liable. The National Electrical Code, often abbreviated as NEC, is a widely adopted standard for electrical installations. While the Kansas Electrical Code governs installations in Kansas, it is generally based on the NEC. States and municipalities often adopt the NEC with local amendments. Therefore, understanding the NEC is beneficial even when working under a specific state or local code. When running electrical lines underground, several factors must be considered in addition to the burial depth and trench dimensions. Firstly, the type of cable used must be suitable for direct burial. Cables such as underground feeder, also known as UF cable, are designed for this purpose. These cables have a robust outer jacket that protects the conductors from moisture, chemicals, and physical damage. Secondly, the cable must be properly sized to carry the intended electrical load. This involves calculating the amperage requirements of the devices or appliances that will be powered by the circuit. The cable must be large enough to handle the load without overheating. Thirdly, overcurrent protection, such as a circuit breaker or fuse, must be installed to protect the circuit from overloads and short circuits. The size of the overcurrent protection device must be matched to the ampacity of the cable. Fourthly, proper grounding is essential for safety. The grounding system provides a path for fault current to flow back to the source, which helps to trip the overcurrent protection device and clear the fault. The grounding system must be installed in accordance with the electrical code. Fifthly, when running cables underground, it is important to avoid running them under driveways, sidewalks, or other areas where they could be subjected to heavy loads. If it is necessary to run cables under these areas, they should be protected by a conduit. Sixthly, it is also important to consider the location of other underground utilities such as water pipes, gas lines, and communication cables. Contacting the local utility companies before digging can help to avoid damaging these utilities. Seventhly, before backfilling the trench, it is a good practice to install a warning tape above the cable. This tape will alert anyone digging in the area that there is an electrical cable buried below. In addition to the requirement specified in Article 300.5 of the Kansas Electrical Code, other sections of the code may also be relevant to underground wiring installations. For example, Article 310 provides information on conductor ampacity. Article 250 covers grounding and bonding requirement. Article 406 covers receptacles, cord connectors, and attachment plugs. Article 547 covers agricultural buildings. Consulting with a qualified electrician is always recommended before undertaking any electrical work. A licensed electrician can ensure that the installation complies with all applicable codes and standards. They can also provide guidance on selecting the appropriate materials and methods for the specific application. When working with electricity, safety should always be the top priority. Always turn off the power to the circuit before working on it. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. Never work on electrical equipment in wet or damp conditions. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. Keeping the safety is the priority. Let us discuss the consequences of not following minimum depth. Firstly, if the wiring is not deep enough, it may be subjected to physical damage from shovels, gardening tools, or other equipment. This can damage the insulation of the wire, which can lead to electrical shock or fire. Secondly, if the wiring is not deep enough, it may be exposed to freezing temperatures. This can cause the wire to become brittle and crack, which can also lead to electrical shock or fire. Thirdly, if the wiring is not deep enough, it may be exposed to moisture. This can cause the wire to corrode, which can also lead to electrical shock or fire. Fourthly, if the wiring is not deep enough, it may be a tripping hazard. This can cause people to trip and fall, which can lead to injuries. Fifthly, if the wiring is not deep enough, it may be a nuisance. This can cause people to complain about the wiring, which can lead to problems with neighbors or the city. It is important to follow the minimum depth requirements for electrical wiring to ensure the safety of people and property. Remember to always consult with a qualified electrician before starting any electrical work. It is also crucial to understand the terminology used in electrical codes. Here are some definitions of common terms. Ampacity refers to the current carrying capacity of a conductor, expressed in amps. Conductor means a wire or cable used to carry electrical current. Circuit breaker is a device that automatically interrupts an electrical circuit when an overload or short circuit occurs. Grounding is the connection of electrical equipment to the earth to provide a path for fault current. Overcurrent protection is a device, such as a circuit breaker or fuse, that protects a circuit from excessive current. Raceway is an enclosed channel designed to hold wires or cables. Common types of raceways include conduit and electrical metallic tubing, abbreviated as EMT. Service entrance refers to the point where electrical power enters a building. Understanding these terms will help you to better comprehend the requirements of the electrical code. The Kansas Electrical Code, like most electrical codes, is updated periodically to reflect changes in technology and best practices. It is important to stay up to date on the latest version of the code to ensure that your electrical installations are safe and compliant. To summarize, when running electrical lines underground in Kansas, adhering to Article 300.5 of the Kansas Electrical Code is essential. Firstly, ensure the cables are buried at least 18 inches deep for the first 10 feet from the building and at least 12 inches deep for the remaining distance. Secondly, dig a trench that is at least 6 inches wide for cables up to 4 AWG and at least 9 inches wide for larger cables. Thirdly, the trench must be at least 12 inches deep for all cables. Fourthly, use direct burial rated cable such as UF cable. Fifthly, size the cable appropriately for the load. Sixthly, provide proper overcurrent protection and grounding. Seventhly, avoid running cables under driveways or sidewalks if possible. Eighthly, contact utility companies before digging. Ninthly, install warning tape above the cable. Tenthly, consult a qualified electrician if you are unsure about any aspect of the installation. By following these guidelines, you can ensure the safety and reliability of your underground electrical system.